Okay, question 7 asks us to complete the following table. I had adapted this from a different class, so in your copy it probably says something about the hydroxide ion or OH minus, but for this class we're not going to deal with the hydroxide ion. So we're going to complete the following table, and we've either been given the acid concentration or the pH. After we find either the acid concentration or the pH out, then we'll classify the solution as acidic, basic, or neutral. So the equation, if we're given the acid concentration, to find the pH we use the negative log of H3O+. Now remember that H3O+ can be abbreviated using H+. So if you see H+ somewhere instead of H3O+, just remember that they're talking about the same thing. The other thing I want to remind you is that 10 to the negative fifth is equivalent to 1 times 10 to the negative fifth. So if that, and why that's important is because anytime the coefficient is 1, like here, we know that the negative log of that number is the same as the positive exponent. So to put that in a different way, the negative log of 10 to the negative fifth, if you plug it into your calculator, sorry, I don't know what that was doing. If you plug it into your calculator, it would equal 5. But I can tell when there's a 1 as the coefficient that the exponent here is a negative 5, so my pH would be 5. Now remembering the acid-base scale, we know that a pH equals 7 is neutral. Basic would be less than 7, greater than 7. That's not going to help you if I mess you up, is it? Basic is going to be greater than 7, so 8, 9, 10, 11, 12, up to 14. And then acidic is when you are less than 7, so 6 and below. So a pH of 5 is less than 7, so it would be acidic. Now, if you're given pH, if we rearrange the pH equals negative log of the acid concentration, mathematically, if you rearrange it, this is what you get, that H3O plus equals 10 to the negative pH. So if I wanted to find the acid concentration and I knew pH, I would say that this equals 10 to the negative 9.4. Now, there's a couple ways you could enter this into your calculator. You can either just plug in 10 and then the little caret key or top key like that, and then the negative sign and 9.4. That would be one way. Or you can type in, it would be the second button. Then you'd hit log, and on your computer you would see 10 up like this. Then you'd hit the negative key and then the 9.4, which would then look like down here, negative 9.4. Whoops, 9.4. So if I do that into my calculator, so on my calculator I have the little arrow up key, so I hit 10, up, negative, not subtracting, 9.4, and I get 3.98. So if I had to round that up, I would say 4.0 times 10 to the negative 10. Now, really, let's see, my pH has only one decimal place, so if I'm really doing this correctly, I would just have one number in my coefficient. But if you were to answer on on something 3.98 or 4.0, I would accept that. So 9.4, the pH, this pH is greater than 7, so this is a basic solution. Now the final one gives us an acid concentration, so pH equals negative log of 6.8 times 10 to the negative 7. So I'm going to plug this into my calculator. Remember, it's the negative sign, not the subtracting sign. So it's negative log, then I put in 6.8 times 10 to the negative 7. And I get 6.17. Now the crazy rule with how many digits past the decimal is that if I have 2 digits in the coefficient, then I would round it to 2 digits past the decimal. In this example, if you would have if you wrote 6.2, I would still accept it as correct. So this would be 6.17, and this one is also, whoops, why was I almost writing basic? It's less than 7, so this solution is acidic. So remember, 7 is neutral. Then if you're less than 7, you're acidic. And if you're greater than 7, you're basic. Now question 8 is another one. Now in this question, it says write the neutralization. Acids and bases react to neutralize each other, and this is a double displacement reaction. And so what it does is it switches partners. We've done these type of reactions in different situations in a previous chapter. So if I'm going to switch partners, the H goes with the OH, and the K goes with the Br. So this is H plus and OH minus, which makes water. And acids and bases will neutralize each other, and one of the products is always water. And then K plus goes with Br minus. A plus and a minus will cancel each other, so this is just KBr. And so it's a double displacement reaction where one of the products is water and the other product is an ionic compound, which is also known as a salt. So in this chapter, if you see the word salt, it's referring to an ionic compound that is formed between the reaction of an acid and a base.